Well, design must demonstrate compliance before drilling begins. That is the central message here. Before the first drilling activity, the operator must show that the proposed well can be drilled safely, maintain integrity, and manage environmental and operational risk across its life cycle. The emphasis is on demonstration, not aspiration, not intent, but evidence that the design is technically sound and that the risks have been identified, controlled, and documented before field execution.
The first requirement is well objectives. A regulator needs to see a clear purpose for the well, why it is being drilled, which formations are being targeted, what data will be collected, and how the well will be completed, suspended, or decommissioned.
That objective then drives the engineering basis. It informs the well trajectory, casing design, drilling fluid selection, pressure management, and eventual completion approach. So the objective is not a project description, it is the control point for the design. Precisely. If the objective is unclear, the regulator cannot confidently assess whether the design is fit for purpose.
The second requirement is risk assessment. The operator must identify credible hazards and show that risks have been reduced to an acceptable level before drilling proceeds. That includes geological uncertainty, abnormal formation pressure, lost circulation, borehole instability, well control events, environmental impacts, and operational hazards.
And the regulator will expect controls, not just a hazard list.
Correct. The assessment must identify preventive and mitigation measures. The practical test is whether foreseeable problems have been addressed during planning rather than left to be managed after they occur.
That leads directly to design approval. The approval package should contain the technical evidence, formation pressure and fracture gradient predictions, casing and cementing programs, drilling fluid specifications, directional drilling plans, well control arrangements, and contingency plans. The hydraulics evidence matters here as well. It does. Circulating mud must cool the bit, remove cuttings, and support pressure control. Pressure losses through surface equipment, drill pipe, drill collars, bit nozzles, and annular sections need to be understood, so pump capacity and operating limits are adequate. Where drilling mud behaves as a non-Newtonian fluid, the design must account for plastic viscosity, yield point, flow regime, critical velocity, and annular hydraulics. These are not academic details. They support safe circulation and hole cleaning.
In regulatory terms, the design package must connect calculation to control.
Exactly. Approval provides assurance that the well is not simply drillable but drillable within a controlled technical envelope. The fourth requirement is barrier philosophy. The well must maintain multiple independent barriers to prevent uncontrolled flow of formation fluids.
Those barriers can include drilling fluid hydrostatic pressure, casing strings, cement sheaths, wellheads, blowout preventers, and completion equipment.
The key principle is independence. Yes, if one barrier fails, another must remain available to maintain well integrity and protect people, the environment, and assets. That aligns with the broader drilling controls. Mud pressure is managed against formation pressure, blowout preventers provide shut-in capability, and casing and cement support isolation through construction and completion. From a regulator's perspective, the outcome is evidence-based assurance. The operator must demonstrate that the well can be constructed, operated, suspended, and decommissioned while maintaining integrity throughout its life cycle. The focus is not merely obtaining approval, the focus is proving that legislation, risk management, fit-for-purpose design, and environmental protection have been translated into enforceable technical controls. The practical question for approval is straightforward. Does the design demonstrate that hazards are understood, barriers are defined, and controls are ready before drilling starts? Regulatory compliance starts with engineering design. A well is considered safe because risks, barriers, and technical controls are built into the design before the first drill bit enters the ground.